Okay, so welcome to this question on the 2014 DEB higher level mock exam, technical graphics, question QB6 higher level. So ellipse and the parabola. So security firm logo. So ABCD is an ellipse. Tells you very little info in the text other than that, right? Well, I have the major axis A to C. I can see I don't have the minor, the minor diameter. I don't have that. I do have a point P on the curve. I have that. So how we're going to find an ellipse is we're going to use our major circle and our point on the curve. That's how we're going to get it. So point P, is over 50, which a lot of my students doing the test this year didn't put it in. So we're going to go over 50 and up 20, right, to find point P. We're going to draw in our major circle. Now, from point P we have to go parallel to the minor axis until we hit the major circle. Okay, I'll zoom in here. So parallel to the major axis until we hit the major circle. From there we're going to join back to the center point. Now that doesn't have to be at 30 degrees or 60 degrees. That line can be at any angle. And then from P we're going to go parallel to the major axis until they intersect. That's a point on the minor circle. And then we can draw in then our minor circle, and we're away then at drawing the ellipse. You know yourself then, you can do your 60-30 divisions, so you can. Right, so we'll begin. The major circle is 130 millimeters. So we're going over 65 for a point on our major circle. Okay, we're going over 50 and up 20 for point P. So up 20 for point P. Now, we can draw in our major circle . Okay, now from point P then, as I was saying on the sketch, we're going to go parallel to the minor axis until it hits the major circle, join back to the center, then from P parallel to the major until it intersects the sloped line. So I'm going parallel to the minor axis, I'm joining back to the center, and then from point P I'm going parallel to the major axis until they intersect. I have a point then on my ellipse. I'm going to draw in my minor circle then. And you know the crack from there, most of you. We're away then for drawing the ellipse. Now in that particular year you would have got 9 marks for finding the axis, 9 marks for the ellipse construction, and 9 marks for drawing the ellipse. Okay, which was probably a bit too much now to be given 27 marks for that part, but however. So there's the bottom, top of the ellipse, and the left and right sides at the vertices. So I'm going to pause and freehand sketch them in. Keep your hand inside the curve. So look, that half, move your body or the sheet, sketch that half in, and then I'm going to have to turn around to the other side. Now, so with that done, okay, the curves XWY, XTY and SVU are identical portions of the same ellipse. So these 1, 2, 3, okay, now they're all identical. So the length of them is 100. So basically this section of the ellipse is moved down for XWY, it's moved down, and then for SVU it's moved down as well. And then XTY, okay, is this portion here, or that one mirrored around. So that's just pushed there. So what are we going to do? How are we going to do this? Right, we're going to take our compass and our set square. We're going to measure over 50 right and left, and we're going to go up and we're going to segment out that section. We're going to pick 1, 2, 3, 4, 5 points. Now you're going to take your compass and set it between or and the center line, and all the distances remain the same. Okay, so from B I'm going to step that distance with the compass, that's W, and then for these 2 points I'm going to go project straight down. I'm going to mark the distance with my compass as well, and then with SVU it's going to be or to S. S is down 80 from the center line. We're going to step it there. And then you freehand sketch those points in. Okay. And then XTY. Alright, we do the same thing, just the opposite way around. So we take that distance, mark it from the bottom of the curve, and D. There we go. Right. So once again, now I can just pick one point here in the middle of the ellipse, so just one in the middle there. So just, if you're really caught up on this dimension, it's 25 there, 25 from the center line. Point is down from P. That's or. Now I'm going to do XWY, so the one here. So I'm going to take the distance from the center line to or, and look from where it touches the ellipse. to mark it down. From B, that's W, has to be on the ellipse here, your compass. And that's Y, W, B, R, is there an X? Now, I'm going to do the bottom one, SVU, so I have to go down 80, so this is point S, this is point U. Now I'm going to set R to S, back it from here, here's V, so just a reminder that was from the ellipse. And then you see the way P and U are there, or U is there. Right, the bottom half, same idea. So this distance here, alright, ellipse. Okay, I'm just going to fix that. Okay, so that's fixed there that I was doing. Now, I'm going to pause and freehand sketch those curves in. So the three of them. So that's them sketched in. Now the parabola. Okay. Here we need a rectangle. We know the base is 50, so this is where you could just divide into 10, because you're told. Now this one, you don't know the height of, so you're going to have to divide it into equal parts. I'm going to draw a line at any acute angle. I'm going to mark 5 equal parts. 1, 2, 3, 4, 5. Join it back there. There. Now, the points on the line parallel to the axis go to the vertex. The points on the line perpendicular to the axis go parallel to it. One touches 1, 2 touches 2, 3 touches 3, 4 touches 4. You can sketch them in. Heavy to there, light here. You're going to have to draw the light part in. And then you can mirror across for the other side. Okay? Or to save you time, well, the first one is 10 in, so you can just measure 10 in. Second one is 20 in, or 30 from the center rather, so you can mark 30, so on and so forth. So here's the rectangle. 10, 30, 20, 10. And we know any acute angle five equal parts. And the last point, the corner, so this point to the vertex where it hits the first one is a point. The second one third one, fourth one. Okay, and then we can just put the points to the other side, look, across. Right, now to mirror it over, the first one is 40, second one is 30, $20, $10. Okay, and I'll freehand sketch them in. So that's it there. Okay, now the tangents. So we need to find the focal points for any tangent. Okay, now you're given the point OR, PQ and QR are given, because like OR, even though it's not well shown there, OR is just directly across from P. So this. Just let me check the marking scheme. I'll find it, but we're fine. Now, so we need the focal points, so we're going to take half the major, swing from the top of the minor. Now F1 to OR to F2, set the angle with your compass. So set your compass to any radius, the longer the better. So I'm just going to, the longer the better. So swing your arc. Oh, sorry there. So that's the bisector. We'll do that again. The normal and then the tangent. The reason it's safe to assume that it's a tangent from the point on the curve. Okay, it is. is because Q is not given to us, so it couldn't be a tangent from a point outside. So, take half the major, swing from the top of the minor so that's F2. So I'm doing the same thing just from the other side. F1. Set your compass to any length, swing an arc. There, re-swing. And where the arcs intersect, join back to P. So that's the normal. And then the normal is perpendicular to the tangent. So there's Q. I docked myself 2 marks there, so that ellipse was just a bump too high, or a contour too high. Same right there. It's Q. And then I'll heavy all that in with pen and zoom out. And there we go. Cheers, thank you, bye bye.